Welcome to the coding part of this video. So let's get into it. Number one step, we will do the EDA process and check whether the data is linearly separable or not. So we're going to import pandas as PD. So we're going to read the data and print the top 5 rows and plot the scatter plot using matplotlib.pyplot as PLT. And we're going to scatter the data age, glucose, and C data outcome. And in here, we're predicting whether the person has diabetes or not. As you can see, the data are overlapping, so it is not linearly separable. Next step is the feature selection. First of all, we're going to store variables in X, like age and glucose, and Y, which is going to be outcome. Now we're going to divide the training and testing data. So from sklearn.model selection, import train test split. Train test split splits the training data and the testing data. So sklearn xtrain, xtest, ytrain, and ytest is equal to train test split. XY test size 0.25 and random state is going to be 42. Now we're going to print the shape. So xtrain.shape, xtest.shape, and so on for y. And as you can see, we got 576 by 2 and 192 by 2, 576 and just 192. Now for our last step, the prediction, and we're going to train with SVM. So from sklearn.svm, we're going to import SVC. SVM is equal to SVC kernel is equal to RBF. Now we're going to fit xtrain and ytrain. And ypred, which means predict, is equal to svm.predict xtest. Now we're going to go on and predicting, and then we're going to print ypred. Now we're going to calculate the accuracy of the model. So from sklearn.metrics, we're going to import the accuracy score. Accuracy is equal to accuracy underscore score ytest ypred multiplied by 100, and that is our accuracy. As you can see, these are the list of patients we have. 1 means diabetes and 0 means no diabetes. And our prediction is 72.91. With SVM, our prediction is 72.91. Thank you so much for watching this video, guys. If you had any queries, then please do let me know in the comment section below. I'll see you in my next video.